Okay, let's do this. I'm Adam. Thanks for listening. Brian, welcome to another episode of Engineering.
Thanks for the invite, buddy.
So we've decided on that as a name. It's Engineering. I like it.
Oh yeah, it's super clever, and it hasn't been taken on the internet, strangely.
Exactly. I was about to say, of prime importance. It seems like so easy a pun that I don't know how it's.
I know. I'm shocked. We need to lock it down hard.
What I know, they don't know.
We just file some sort
best.
of paperwork.
I've been doing my best. Yeah, if you want to listen to this, if you want to if you're listening to this and you want to dig into it, you can probably find remnants of my slowly getting the SEO empire for Engineering set up. But I do it in my free time, so it's like we have an address. It probably just still points to GoDaddy, and we have SoundCloud, YouTube, all these other things locked down. So you can go follow us, and someday all that information will be there.
Feel free to like empty profiles. I think that's cool. That'll encourage us to get that shit going.
Well, you don't give a shit about. You just want to not miss the update if we put up a new episode, right?
Yeah, no one's sitting on SoundCloud. They're like, oh, that was good. Let me hit the next button.
But they might be. I'm not.
Yeah, maybe they are. I don't know anything.
I have no. I'm slowly becoming.
I'm not as hip as I want to be running a podcast on the internet.
An out of touch adult.
And we might still shower people with some topless science themed pieces, even though that's not our name anymore, just because I think it's a little more provocative.
By topless science, you mean just you will continue to not wear a shirt?
Maybe just pictures of me without a shirt. Maybe pictures of other people without shirts. I don't know.
I don't know that I left any reference of topless science in the previous two episodes.
I think it's okay.
No, I have no problem bringing it up. I just think it's funny because they just didn't. I tried to put them in. I just didn't, get the episodes to be too long. The goal is to eventually not have to edit at all, but it means one of two things have to happen. We got to get good enough at this that we can finish it up in an hour, or people have to care enough to hang around for the part that's not necessarily interesting.
Both of those are going to happen, but I think key is to stay on task, which is probably a great cue for us to hit the get to the hit list here.
Okay, so episode 3. What's you want to introduce the big topic we'll get to before we bounce a few off the hit list?
Today on the agenda is quantum computing and just computers and stuff in general.
Right. I mean, that means we're going to have to back up to what the hell a computer does before.
Into things that are intelligible before we ramble our way through quantum computers.
It sounds like a very narrow topic, right? Rock on. So hit list stuff. Here's what I got. The note says Velcro. And I was thinking about this.
Ooh,
so
Velcro.
Why I was tying my shoes the other day and I was tightening the laces and I thought, why am I doing this? It was a pair of dress shoes or something, right? So they still have laces on them. But every other pair of shoes I have either has elastic on it or some sort of Velcro system. So I can get them on and off really quickly. And it's crazy to me how pervasive laces still are and how inconvenient they are.
I've wanted Velcro shoes for fucking ever, and I constantly get in this conversation and then I don't go get them, so it's my own fault.
So here's what I think is interesting. I also recently purchased a smart lock. It's a deadbolt that I can control with my phone, and remember the thing that the millionaire in Garden State invented was silent Velcro?
Ooh, that's a smart invention. That sound just came from Extreme Velcro that I use to attach the sound panels all over my room.
This is the thing. I don't know if people realize the vast array of Velcros available. I have 3 different rolls of Velcro in my house at all times. and they all have different
tons of
different
Velcro.
different like how would you describe this from an engineering standpoint? They have higher
I was
load
just
capacity.
right. I was just gonna say the like industry name
Right.
for Velcro is hook and loop. And there's like shitloads of different kinds. It's used for all kinds of stuff.
Yeah.
It's a damn clever invention. I
But
mean,
you can
hell.
get stuff that like an inch by an inch or like 2 inch by 2 inch square will hold 40 pounds.
How dope would it be if your entire wall was covered with Velcro, like the soft side? So not only you'd have like a
Like the space station.
yeah, totally right. There's Velcro everywhere in this.
That was part of the problem. Velcro that they used on the walls in the Apollo 1 capsule, which that's the one that like the test flight caught on
Right.
fire and killed the astronauts.
I think
right?
so.
Well, first, pure oxygen is super flammable, but also problematic is the Velcro that they were using was super flammable.
Ooh.
And so what happened was the short circuit, I think it was, sparked and it hit a piece of Velcro, and that piece of Velcro went, and then that caught the oxygen.
No bueno.
The guys actually died of asphyxiation, though, apparently, because that would clear out the oxygen so fast they probably passed out almost instantly.
Ooh, I don't know.
Or after a
That's
couple
probably better
breaths,
than burning up while you're awake.
Yeah.
Burning seems like a really bad way to go.
Anyway, that was heavy. So
off topic. We'll delete that later. That was too heavy.
But yeah, that was too heavy. But Velcro.
We're
so the crazy applications. I do wish Velcro was everywhere. Like I wish I had a wall of Velcro in my office. I might just set up a wall of Velcro in my
that actually is a
office
really neat idea.
to just hang things on.
Oh, cool. With all kinds of little like adapters. There's a good business idea.
Yeah.
Little
We've
things
talked
to
about
hold
this
shit.
before. Remember,
It's
we
a
were going to
really
make a
good idea.
Velcro.
You did build this. You sent me a video of that a while
we
ago.
made a whole. I lived in a house for a while where most things were hung with Velcro.
Interesting.
Just a 12 by 12 panel of it, like in a picture frame,
right.
was actually a really super useful thing. You had to screw
bet.
it in at the corners so that you could freely like off the wall, but that's not a big deal. Or into one stud. Yeah, totally. That'd be awesome in a studio.
It would be super
There's
awesome.
Velcro all over the place. But so here's the thing. So I got this smart lock, and I frequently don't use the smart lock because every once in a while it takes a little while to connect. And so that creates just the tiniest bit of inconvenience that's enough that I default to the old option, the key, which is just shoom, click, done. Right?
Yeah.
So that's a place where I see smart lock adoption taking time because of that level of inconvenience, right? It's a frequent thing, right? You have to design something, but you have to design something that's like, it can be better in this one respect, which is I can control it with my phone. I don't need to worry about keys. I can give people like a 3-day invite if they're staying at the house and they can use their phone to get in. Like, it's super handy. I can check the status of the lock over the internet.
Not really important, probably.
Not important compared to it not fucking up my routine on the way out the door when I'm just trying to lock the deadbolt, right?
Well, this goes back to what we talked about last time, which is like the amount of improvement you get with each new design. Like a lock is really important. It keeps people from just walking in and taking stuff from your house. But the key is a really good solution. It takes like a second to pull a key out and unlock your door. And so to have it on your phone, it's really a pretty marginal improvement over a key.
Right.
You know,
the stuff it starts to add is not particularly important, except where you can give other people access, which I have other people that I give keys to just in case, like we need a spare key.
Yeah, that's a good.
It sort of eliminates that, which is cool, but it's not cooler than the inconvenience of sometimes it won't connect, and I'm like, fuck, now I got to get my key out, and I just burned 3 minutes at the door, which is not that big a deal.
Oh, you're pissed,
but like
swiping and restarting your
it's
phone.
a place in my life where I'm used to that 3 minutes having been a split second, and so it's really
right.
I hate it when it happens.
I hate my phone all the time. I was pounding my phone on the dashboard yesterday because it wouldn't make phone calls. So I was driving home. I'm like in traffic at like 7 o'clock, like rush hour traffic. And I can't make a fucking phone call to tell someone that I'm going to be late for something. And I'm pounding it. I'm like, if I hit it hard, it'll make a phone call. It didn't reply to that. It didn't like that.
So here's my
attitude.
Considering that as the problem of like, okay, so we want to cruise toward convenience, but also Like you're solving the problems, but you're also doing it in a way that just essentially makes life better, not more difficult as a trade-off for the solution that you provided. Like not being able to just close your door and leave is a small, like the having to stop and turn a key is a very small inconvenience in comparison to the security that you get by having a lock on your door. So given
Yeah. Although I do have to point out that it can't be that convenient to lock the door, because I know a lot of people that just don't lock their
Yeah, that's
doors
fair.
because it's a pain in the ass. So they're houses that are just wide open all the time, and it's purely a convenience thing. Don't want to carry a key. Don't want to take the 5 seconds to lock the door.
So this is a great segue.
It's kind of dumb,
because
but I
those
understand.
same assholes probably wear shoes with laces. Why? Why do those people wear shoes with
Yeah,
laces?
I can confirm that.
If they couldn't be bothered to pop a key in, close the thing in order to have security in their house, but they still take the time to tie up shoes when Velcro exists.
All the shoes that have Velcro are really ugly, I think, is the problem.
Well, there's another business idea for you then.
If they were stylish,
start
like
a
dress
sexy
shoes,
Velcro shoes business.
why would you have fucking laces?
You're right. They probably are all like you know,
Sexy
podiatrist
Velcro shoes.
loafers.
I gotta see what comes up when I search for sexy Velcro shoes on the internet. It's for sure gonna be porn with
Isn't that one of the
Velcro
rules of
shoes
the
involved.
internet, though, that you can,
Whew.
if
Sexy
you can
Velcro
imagine a
shoes.
thing, it's been sexualized somewhere on the internet.
Probably, if you can imagine a thing.
You
There's
can
just-
probably
there's a-
screen
I'm
share.
gonna go to the images. There are a lot of strange results. The
They're all system
internet's just
video.
so goddamn slow down here. Let's move on. There's a load in 17 minutes.
But so that's my thing. Here's where I think it gets really interesting. I think it's because as a landmark, like with our children, you know, tying your shoes is like a landmark achievement of intellectual capacity and dexterity in like culturally in our development as a child.
Yeah, for sure.
Like it's a thing that happens during the day that you tell the parent that comes home from work about proudly. He took his shoes today. The rabbit goes out of the hole, around a tree, back in the hole.
Yeah, totally.
Why? They don't need to tie their shoes. There's Velcro. I think that's the reason we still do it. I think there's cultural baggage
I know, it's
around.
so dumb.
Like I think secretly everyone's a little proud every time they tie their shoes in the morning. Like, fuck yeah, I still got it.
Still got the dexterity, mental clarity. I do want to point out that the 15th image result for sexy Velcro shoes are these super cool shoes that my girlfriend owns. So I'm gonna make sure I comment that I didn't know they were Velcro, but that makes them even more dope. So
I'm wishing in my
gotta
head
compliment
that
on
these shoes are like some crazy ass 70s platform disco shoes. Like they just Velcro up the side, only like 8 inches.
They are kind
that's
of
a crazy.
They're
but
cool.
Bootsy Collins would be wearing these, big hat.
It's a weird. It's hard to describe. I'm gonna try though. They're
very Parliament funkadelic.
They're like wedge skate shoe, funky platform shoes with Velcro.
They make those, but that look like athletic shoes, but because they look like they're not wedges. They look like just high tops. I've started seeing girls wearing those at the gym.
Yeah, totally.
It's really not good for you, anatomically speaking. It's just funny.
Yeah, that's
it's
not
funny
healthy.
that they're like, well, it looks like an athletic shoe, so this must be what I wear.
I appreciate
to the gym.
style.
And I wear those toe shoes, so I don't give a fuck.
I would work out in bare feet if I could, but I don't think they'd let me.
Yeah, I wish the gyms would allow it, but I think other people probably ruin it for us.
The dirty feet would be the problem, not the amount of sweat I leave on every machine.
Other people's dirty feet.
Other people, yeah, fuck other people. I should be allowed to go barefoot though.
I feel you.
That's not very Zen engineering of me.
If I just wear socks, I like. Sometimes you get away with it for a little while. Generally, people don't ask me questions. I used to take my shoes off all the time until I discovered the toe shoes. I used to work out in socks until a trainer would say something.
Oh, interesting. I kind
A
of like
lot
that.
of them, if it's not crowded, a lot of them will leave you alone.
Yeah. All right, on to the next.
Okay, so I feel like that one took a little while. So let's do quantum computing. Let's do our heavy
Ooh.
topic. I got nothing else
Ooh.
interesting for the hit list this week.
Cool.
Or that's not true. I have 6 other notes here. I just don't remember what they mean.
That's fine. We could make things up.
Which is what usually happens. One says startup economy. I have no idea what that was pertaining to. Renaissance. Markov chains. Do you know what a Markov chain is?
Ooh, I feel like I should know what a Markov
software
chain
term.
is.
It's something like recursive program, like a program that the next line of code is written by the program itself, and then you just let it go.
Ooh.
Or something like that. It's a program that responds to something
Yeah.
else and then proceeds in automated fashion. You can find Reddit threads where the comments are completely controlled by Markov programs, and they look remarkably like normal people talking. They don't say anything, but they really are convincingly Reddit threads. Anyway, I came across a headline about it and was like, maybe that could be our big topic, because I'll have
that touches on an interesting
maybe
topic for
a
future cast. We should really be in our zone before we start tackling topics like what is consciousness, because that's what we were just headed towards there.
So quantum computing,
which we might have to kind of roll back a little bit and just do some regular computing filler.
I feel like it's a buzz term that you hear now.
For sure.
Like every once in a while I see a quantum computing headline, or it'll show up in like a crime thriller where somebody's like, well, he has a quantum computer encryption, blah, blah, blah.
Run it through the quantum computer.
What does that even mean, right? So what I want to get to is the difference that makes quantum computing such a crazy ass important, like giant leap from where we are.
Yeah, start with electric circuits and logic.
What? Yeah, exactly. Okay, so what is a computer? From an engineering standpoint, tell me what a computation engine consists of.
So, a computation engine. That's a good way to put it.
Like,
what are these?
That's what Turing called it, I think, a computation engine.
Yeah, something like that, right? Because at his time, computers were what you called the people that sat and did math by hand with slide rules.
Right.
They were the computers, the people doing computing. So at a really basic level, a computer, or at its most basic level, a computation engine is just logic that you put together with essentially yes/no questions that when you stack them together appropriately, you can create you can answer more complex questions.
Turing's machine, that people saw in the imagination game or whatever that was called.
Right.
Is that what it's called? I think so.
Something like that. It had imagination in it.
Like that big crude room filling machine before microchips and the stuff that we have today.
Yeah.
Was what? As a series of...
That was all mechanical, I think.
Right. Before microchips, we used to use a room full of things to represent like these yeses and nos. And in a really crude sense, you could use it to solve a problem, because you write code,
right?
And that code says, if this is a 1 and this is a 0, do this. Like once you can remember states like that, you can start writing code to manipulate those states.
Right.
Code is all just a giant ability to process a really, really complicated string of if-then statements.
Yes, that's a good analogy, because it's a flow chart.
Right. And so microchips were the first place to take this thing that used to fill up a room and make that same process of being able to store the state of a complex system of if-then statements in one space, one physical space. And when they talk about a processor being stronger, all they're really talking about is increase the capacity of that chip to process and understand that chain of if-then statements.
Yeah, at the level of the chip, it doesn't do anything. It's built and it's a solid piece of material, right? And then there's really low level code that runs on top of that knows what the chip looks like, and it has kind of the intelligence of hey, these electrical signals came in and went out over here.
What we're talking about is, like you said, it's the chip is inherently inert. And it's set up so that if you run a signal into it in a certain way with certain commands, the whole system responds, and out the other side pops electrons that in a arrangement that give you an answer.
Yeah.
Um,
It just ran your flow chart real fast. Yep.
and you can do a lot of stuff at borderline the speed of light.
Yep.
And so when they're trying to make microchips smaller, they're starting to butt up against problems like a channel can't be skinnier than a single electron. And then they can only fit so many of them so close together before electrons jump paths and things like that that get sloppy.
You've got a lot of weird behavior. You not only get the big one that we deal with is heat right now, which everyone hears a lot about, which is why these big computing centers need to have water pumped through them and air conditioned, why they get really hot. But you're right, we're getting to a point where there's a physical limitation with the current design of microchips. We won't be able to make them any smaller in the type of material that we use. So we either need to move to a different type of chip or a completely different type of computation, or one of the really interesting spaces is a completely different type of manufacturing. Because if you could manufacture microchips differently, there's some interesting new orientations that you could do with them that are completely different than how they work now.
That the answer to that, as I understand it, is quantum computing. But we'll get there in a second, because first we got to talk about why do we need more computing power?
So the processor has like a series of flowcharts built into it, right? You put an electron in one side, it goes through the flow. You put electrons through in different inputs. It goes through the flow, and out comes electrons at certain ports on the other side. And so it made decisions for you. The software that you put on top of it is really no different. It's exactly the same. It's a series of yes, no questions, a series of if then questions, right? If 5 equals 5, if this number equals this other number, output a certain thing. And so the software is neat because we've reduced the microchips to like the fundamental flowchart questions that have to be answered for every other thing in the universe to be calculated. And then the software is just like more complex layers of flowcharts that humans can then control. So you put into a computer a processor that has like 50 fundamental questions that you can ask it. And then with those 50 fundamental questions, you can then build software on top that abstract out to anything in the world, including Instagram and web browsers and video conferencing. But they all reduce when you look at the logic and how decisions are made and how things happen in the universe and how math is done. It all reduces to these very, very fundamental, almost like yes, no questions, which is what the processor does.
I mean, it all boils down to if then, what in programming are called if then statements, right? If this, then do this.
Yeah, I
if
think
this,
so.
then
for
do
the most
that,
part,
right?
yeah.
And I think that's what defines a binary system. Like it all boils down. My understanding is the base level to this, a 1 or a 0, basically. And so
Yeah, for the most part.
And so
there's some other cool things in computer science, but won't be able to talk about
what
those.
I think is fascinating is, so my exposure to programming versus yours, but even yours to an extent, right, is like you're dealing mostly with like what's the stack here. I hate it when they talk this way because it sounds so exclusive, right? But like programmers talk about the stack that they work with, which is just a set of code libraries. Like, what do you work with, right?
No, it's a good question. I work primarily in Linux, which is an operating system. So this is a cool question because there are these layers to computers, and I don't know them very well, but essentially you can think of your processor, and then there's like software that sits on your processor that interacts with the processor. Then you have your operating system that sits on top of that, and then you have all these layers in there. There are layers I'm missing, but way up at the top, after you're like way abstracted from the processor, you have languages that people have heard of, like Python and PHP. I work generally in one of those two, and they're like super high level languages that are actually written in another language that sit and run inside of other things, and eventually they make their way down through those
Right.
other
Yeah,
layers
exactly. And
into
so
the processor
it's
where it
it's
runs.
this increasingly, like, it's a sort of, they say like you can't screw around in the beginning class of foreign language because the later ones build on that. Like, it's the same idea. There are
Right.
when you
Yeah.
create like code libraries or operating systems, or like there's this constant thing going on of people, programmers, who say here's a subset of problems we want to solve. The tools don't exist, so we're going to build a set of solutions that will help us get closer to this bigger problem that we have. And so even if you know, like Objective-C, Apple just rolled out this Swift language, which is, my understanding is, it's based on Objective-C. It's just a better subset of the same things that you'll already pretty much know for their devices. You see it on the web all the time. Twitter rolled out Bootstrap, which was like a framework for designing websites that was easier and better than the crude JavaScript versions we had before that. But without the complexity of that JavaScript thing, you can't achieve the refined version. But then people start working with that refined version and it gets too complicated. So somebody else writes another program, does a more specific thing, like for the thing that you want to do, right? Like it's just this rapid fire, like problem solving.
Yeah, it's just layers
sort of
and layers and
mechanism
layers
of creating new systems to solve a bigger problem, and then
or
using
more
that to solve a
specified,
bigger problem,
more specific problem.
or you're right, not bigger, but more specified problem. When I say bigger, I think I mean harder to reach.
Yeah. An interesting thing about programming is that at a certain level, this isn't always true, but at a certain level, you can do anything with any programming language. That's the idea. You can do anything with any programming language. You just build them specifically for specific use cases. And it's I think the layering that you're getting at is totally true. If you think about math class, math is a really good example because like you learn these really basic things. You learn how to count 1, 2, 3, 4, 5. Then you learn how to add 2 to 3 equals 5. You learn addition, subtraction, multiplication, division. And then all the other things start to layer on top. Calculus is this wildly complex thing that's used to solve very specific types of problems, a lot of very specific types of problems, but you can't do it without addition, subtraction, multiplication, division. You need those basic tenets that then, those are relatively simple. Everyone gets those, everyone learns those. And then building these more complicated layers on top are used to solve specific problems. And that's where it all comes from. Math is that way. Math's just made up.
Well, and that's a really good example because you think, okay, 1 + 1, right? That's real easy. For a computer, it's not hard, but compared to our brain, which is so much more complicated and has these weird mechanisms of memory and processing that we don't even understand, like it's still very crude. And so to just do 1 + 1 for a computer still kind of takes up a certain amount of computational space and effort and like computational capacity of that processor. And so like a microchip compared to a human brain is so much more crude that like just something we think of as simple +1 is still kind of difficult, and it spits out heat and it takes electricity and blah blah blah, right?
Well, we do all the same things. We're getting to that
Yeah, totally.
consciousness level
Right,
here. What's the difference?
Right. Well, but here's what's
There's no
here's
difference
what's interesting,
as far as
right?
I'm
So
concerned.
this is why binary is important.
Yeah.
Because that's all based on a system that has a 1 and a 0.
Mm-hmm.
It doesn't even have two states. It has a single state that's either like there or not.
Mm-hmm.
And so think about the complexity of genetic code, which has 4 states, because you can be GT, A, or C instead of just A or C. And this is why quantum computing is important, because the current way that chip level thing processes data is based on just an if then, where it's a series of forks, but it's always there's only 2 directions to go on that fork in your flow chart, right? My understanding of quantum computing is it stores states and it understands states based on electron spin instead of electron forward motion. So instead of it being like either an electron is flowing through this or it isn't, as the state of the physical thing happening on a board, it's measuring if an electron is spinning through one axis, the other direction, and it makes it so that we can potentially have code that is not at its core binary. The reason we need this like exponential increase in computing is because we're going to hit a point where,
well, what we're up against is it's a speed issue. And so there's a really neat chart that you can look up that shows the speed at which information travels inside of a computer depending on where you are. And so when you look at the microchip, you're talking almost the speed of light, right? It's electrons flowing through material. So really, really fast, almost as fast as things can move in the universe. And so microchips are really, really small, and we pack a shitload of transistors in there so that you can do this logic incredibly quickly. So all of a sudden, when the microchip, it's processing stuff, all of a sudden when it needs to pull a piece of information to like make a decision, it has to go onto the board. An electron has to travel from the microchip, from the processor onto the board and over to memory. And so that process is insanely slow. It's like tens or hundreds of thousands of times slower. And then you've got the memory, the way memory functions is slower than the processor. And then the way your like your graphics card communicates with the board communicates in a different way. So all of a sudden you have these speed issues. And with processors, we need processors. They just need to, things need to be faster because we're doing more complex stuff. Like we're video chatting over the internet right now, over wireless.
You were saying, like Instagram's a great example. Those filters are like pretty heavy processing.
Video processing is like the hardest thing that computers do
like
these days.
To try to make things look organic on top of a photo is a really complicated process. And It's really impressive that our phones can do that now.
Really impressive. That was in the realm of humans only until very recently. It's very hard for computers to do graphics.
And so if we want to get to like biologically complicated things, or like modeling physics stuff, right? Like if you want to do a faithful prediction of how a storm will behave, you need to be able to process so many variables at once. To do that effectively, that we need more processing power. And that's why something like quantum computing is important, because if we can change the paradigm at such a base level for how this stuff is done to make it tertiary instead of binary, just that change would be such a massively exponential, giantly huge thing for what, like, if we could effectively make it one notch past binary, this is my understanding, any notches past binary, like the ability to compute would get so much faster so quickly that we could start doing things like modeling genes.
And I don't exactly know what the benefit is that you get by adding more like channels of information like that, but I do know quantum computing like solves different types of problems in really efficient ways. Like for instance, one of the things you hear about it used for all the time is security. And so right now, traditional computers are really slow when it comes to like cracking security codes. They're really fast compared to a human. They can do a whole bunch of stuff really fast, but all of a sudden when someone creates a quantum computer, all of a sudden computer encryption will be busted. The way we encrypt things right now will be broken instantly by quantum computers just because they compute things in a different manner, in a way that can be utilized for different things.
Well, so that's a great example, though, because encryption is essentially just a really complicated math problem where everything is scrambled up based on an equation that's so stupid complicated no person could in their lifetime figure it out themselves. But with the right, however many digit key, it's solvable immediately.
Essentially, you take say you wanted to encrypt your name and send it over the internet, you would just mix it up with a pattern that's really long. So you would apply a process to your name that mixes the letters up in a crazy way that I, as a human being, would never be able to figure out how you undid them. But on the other end, the other computer has a component that lets it kind of know the pattern that you mixed it up with. And it's really fast. It's like instant for that computer to decode it. But so you essentially, security right now exists in a way that we just make it really, it would just take modern computers a really long time to unencrypt things. They could do it. A modern encryption right now can always be undone. We just make the pattern long enough that it would take like tens of thousands of years for a current computer to descramble it. And so a quantum computer can do that descrambling function really, really fast. So it'll break security. So ththings aren't secure in the world. Right. They just take a long time. They're just
really well hidden. That's just the treasure map is complicated. But it's a great example though, because that's a huge, it would, like you just said, it would take 10,000 years for a modern computer to do it. A quantum computer in which we're not limited to ones and zeros and binary systems because we're using like quantum mechanical states, I guess, call them or something.
Crazy phantom physics magic.
Yeah, exactly. But it's based on that instead of ones and zeros. Like the computing power goes through the roof so fast that now what would usually take you 10,000 years with the computers that we have, like, would happen instantly. Or I don't know instantly, but certainly faster.
Mm-hmm.
And that's the difference between
Yep.
what we have as computers that we're like, hey, that guy's pretty smart. He can play Jeopardy. Big Blue, whatever it was called. Watson that played Jeopardy, right? Like he's exhibiting a human thing, but our brains are still, I mean, if you think about just DNA as the way of storing information, we can't with our current technology probably ever build a computer that's as complicated as a human brain.
Oh, for sure not. Well, this is an interesting kind of aside here. So I have a friend who worked on a project that was mapping the brain of like this little tiny microorganism, like this. She always said they were worms, but I think they were kind of like these little tiny, like very, very tiny creatures. And so their entire brain, I think, had 27 neurons in it. Humans have like billions or something, or trillions. I have no idea, a shitload of them. But so this little worm has 27 neurons. And so the entire logic of its brain has been mapped. You can look it up online. You can download the software that is this worm's brain. And you can even go to these videos where people they programmed that brain, they programmed those neurons, which operates differently than a computer. It's like a neural network, and I don't even really know what that is. But they programmed it and put it onto a little creature that had the same physical sensors as this worm. They gave it like a heat sensor and a light sensor. And so they have this little like RC car that has this worm's brain programmed into it, and it behaves like the worm does. It like heads towards the same stimulus and so you can like put it on the floor, and it's a complete artificial creature. It is an artificial version of a worm. We mapped its brain, and its brain works just like a human brain. We just have more neurons.
But so that's what's to me is, I guess, fascinating on the quantum computing front is the impact of that kind of thing.
I feel you.
Like we try to model the behavior of cancer cells now, and we're limited by computing power at a certain point because it's a complicated biological process. It's a process that's happening so quickly that to us it seems random and we don't know what to do with it. But it's not random. It's guided by genetic code, which is super complex compared to what we think of as code, but it's still just code. You can read it. Like,
well, what it really does when you get down to it, it's driven by fundamental physical forces in the universe. It's just the whole human body is just a collection of material from the universe that gathered together, and you think it's making decisions, but it's not. It's just this element is attracted to this one in a particular way, and so it joins together and it forms a shape and a thing, and then that thing moves and it responds to other physical forces. And so it's not guided by anything other than physics.
And that physics, and so the code, genetic code, is just a really like comparing, like, so what I was going for is we got binary and we hit a certain complexity, right? Like, so every time you could increase binary by one slot, you're going up an order of complexity, right? It's like, I don't know what the scale is, logarithmic maybe, like more than exponential every slot you get. And so if you think of the complexity of the things that we can do with computers at the size that they are now, and ramp that up that scale, not just one slot to 3, but another one to 4, you're talking about the code that guides the way your body or a biological mechanism responds to the physical universe that you were talking about. Like,
well, there's a size component here too that I think is just as interesting. Like we make microchips and they're really small. I mean, you look at a processor and you're like, wait, there's billions of something on here. That actually is, I think, if you looked at like the size of if you look at the size of a transistor on a microchip compared to like a biological function that's doing logic inside of your body,
right?
It's fucking humongous. The biological system is so tiny. We can't manufacture stuff at that size. Like the things going on inside of a cell, inside every cell in your body has a manufacturing plant inside. It's like fucking making products and shipping them out the door, and that whole cell is is still smaller than a transistor on a microchip.
But so that's what I think is interesting about the idea of quantum computing, right? Because it's us trying to take a step forward but we're essentially chasing the same thing, which is how do you build a series of if-then statements or, commands into a mechanism that can store and process them. And what we have right now is so crude compared to, your brain, or compared to biological storage mechanisms, the code, right? And so then we're kind of back where we ended up at the end of the first episode, which is like everything when you're talking about gravity and this force that we don't understand that unites everything, like all these interconnected forces, it may just be that we don't have the computational mechanism to understand them. So the fact that I don't know what it is, to me, doesn't say like that it doesn't. The fact that I can't process, the fact that I can't see infrared light doesn't mean it doesn't exist. Like, same thing. Forces uniting the universe, right? And I feel like the human imperative is to try to understand that force.
I think what's really cool about quantum computers is not so much what a quantum computer is or how it works, but that we as a species are just barely starting to scratch the surface of computation in the universe, the ability to compute things and build computers. And so we have, for the last 50 years, manufactured one very specific type of computer, and it has gotten, every 18 months, it's followed Moore's law, and it's gotten a little bit smaller, a little bit faster. But all of a sudden, we're like, hey, we got to figure out something new because we're maxing that out. And so all of a sudden, it's like, wait, there are other ways we can be doing these things. And so if you look at the tiny amount of time that we've had computers and look at the effects they've had, to think that that is like the precursor to figuring out all these new ways to compute and create and move information and make decisions, it just opens up this world of possibilities to just do unimaginable things. I mean, a smartphone is so unimaginable. 6 or 7 years ago, 10 years ago, whenever they came out, they've absolutely completely changed the face of the planet. Every single human being on Earth has a computer in their pocket. Everyone thinks about computers all the time now. Nerd culture is popular now, I think, because of smartphones. People appreciate this stuff.
Right. Well, you can do cool stuff with them. It's something that we've known forever because we've been programming websites. But like, how cool is it that you can clickety click, 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 and then a thing blinks on a website that the whole universe can see?
It's incredible.
Or take it one step further with your like Raspberry Pi work and stuff, your Arduino stuff you were doing for a while. Like you can literally make a light blink in somebody's, room. Like if they've set up the right thing for you across the globe.
It's really wild.
Just I hit a button, your shit blinks. Like that's,
really wild.
That's a lot of fun.
There's a there's a concept that I want to touch on here that kind of takes us to the real extreme with computation, and it's you hear that people talk about sometimes, do we live in a computer? Is the universe just a big computer? The Douglas Adams book, what is it called? Hitchhiker's Guide to the Galaxy.
That Don't forget your towel.
Earth was just a computer that someone built to answer the question, what's the purpose of the universe?
What's the meaning of life? Yeah.
And there's an interesting, you touched on this earlier when you talked about storms. How do we actually predict what the weather is going to be like? And the reason we can't do that right now, it's not because we don't understand some basic physics. We can understand chemistry and stuff. It's just that we can't calculate the amount of information that needs to be processed to know what a storm's going to do. When you look at a storm, you look at Doppler radar and you see like a hurricane coming across the ocean, right? And you see this big cloud, and it's pretty clear these days. You can look at it and be like, oh, cool, it's going to be cloudy over here in 10 minutes. You can see it moving around. But to really calculate what's going to happen, you need to go down to the level of the molecules. How is stuff moving? Where are the forces?
Bouncing off other molecules. Yeah.
Right.
Like, and so at some point you need enough computational power. Like if you really wanted to make an accurate reproduction of that, you would need to account for every molecule in that weather system.
And then you get to the point where you need to, not only to really make it accurate, you need to actually calculate what's happening inside of those atoms. What are the electrons and the protons and neutrons, and what are they doing? And then at the deeper level, quarks and all this other nonsense that I don't really know much about. And so you get to this point where you realize, wait a second, to calculate what the universe is doing, you would need the universe to be a computer. You would need each of those little things that we talk about as fundamental pieces of matter, atoms and electrons and protons and photons. you would need those to actually be the thing that you store the information in. And then all of a sudden you reach this point where you say, wait a second, that is where the information is stored. Holy shit, we are living inside of a computer.
Right.
And so that's the place where all of a sudden you're like, what's the difference? There's information and there's state and there's these basic rules that govern the universe. And all of this stuff is on top of it. And all of a sudden we're like, hey, we discovered computers, but no, that's how everything works.
Right. It was just kind of there. That's where, and this is getting into like woo-woo territory, but like
It's a good term.
I have always appreciated the theory that like if you are like eating a psychedelic mushroom or something, that you are actually receiving data from the earth, like in some capacity that we don't know how to process with consciousness, but you're actually like,
I love
you're
that.
pulling out of
I've
the
never heard
fungus, you know, this data transfer that's actually coming from the chemical, like the DNA, whatever code is in their
That's
DNA,
really interesting.
you know, you're just
Yeah.
running it through a foreign computer that doesn't know what to make of it except, and then tries to, because of the way the brain works. It's kind of like Deep Dream, you know,
Totally.
the Google thing where it makes these weird pictures
Yeah.
based on these parameters and they're kind of compelling and weird. I think your brain is doing the same thing with mushroom data when it like causes
Mushroom
hallucinations,
data.
you know.
What a really interesting analogy. I've never heard that idea before. I like that. I mean, that is what you're doing. Everything you do is just information.
I think that's a good place. I think we made it through engineering a little. We made it through Zen a little. If we have any friends left, I think they'll be along for the ride.
This was an interesting one. This was a tough one. All the people who actually know how computers work.
Yes, please.
Contact
No,
us
I
and
really
help
I want to
describe all
understand
the
this.
things
My,
that we
my
do.
specialty is the philosophy side. I'm a big nerd, but it's like I can look at Wikipedia. You know, I'm good at that. But I know there's people who this is what they do, right? We friends, so maybe we'll have them back on later to set us straight.
Yeah, we should definitely we have a couple friends that would love to chat about this stuff. And this is one of the reasons computers are so neat and why they're emerging in culture the way they are and why they're going to be so prolific is because there's no end to what's going on. We just kind of walked through logically how the universe is a big computer. And it just is. It's just information is what the universe is built to do. And the more you see, the more that comes out of smartphones, the more you see humans communicating and sharing information, that seems to be the purpose of the universe, is to share information.
We're processing data. Yeah, like technology feels like some sort of I don't want to say inherent, but it's like
it's nature. My smartphone is
the inclination to create technology is just it's a universal,
it's a natural evolution
law. Like it happens with bees, it happens with ants. We're doing it, and it's bred out of this weird universal need to like communicate and cooperate and try to talk about things, even if it's dumb bullshit like tabloid. But like you're trying to, like even the conversation that people have about the Kardashians has some kind of value, and that maybe it's just two people trying to get on the same moral page about how they feel about.
It is. It's just that that natural universal urge to share things and communicate, which is really beautiful.
And so the real answer to needing more computing is just to get more brains working on the problem, because there are not yet computers better than more brains.
Yeah.
And so what we've decided to focus on with software and with the stuff that we're doing with computers, particularly smartphones, is we are bringing closer together in a communication sense. Like I can communicate quicker with you, brains. Like, so what we're doing is the same thing that you're doing on a chip, where you're trying to make these different processes closer together. Mm-hmm. We're just taking all the best computers in the world, which are all going to be brains, and we're trying to put them closer together so we can all go, dudes, the planet is cooking itself. We need to figure out an answer for this. Hurry up. Think about it.
Right.
And talk. Think about it and talk. And we'll get it.
Yes.
I feel like
that's another great analogy. Smartphones are just bringing our brains closer together so we can communicate more efficiently. It's all totally true. It's so interesting.
There's a guy, Jason Silva, I think his name is. I repost his videos all the time, so follow me on Facebook if you want to catch his shit. He talks about like techno-social wormholes, where it's like what I'm doing with this video right here is I'm recreating the important part of being in a room with you so we can talk about ideas.
Yeah.
At least that's the idea. That's why it's attractive. a lot of the ideas are probably stupid, but there is the capacity in there that will solve a big ass problem by talking about this stuff. And that's the best way we can do it. Just these two computers kind of talking about
Right.
it.
And I think the general implications of all of this technology and bringing people closer together physically to communicate, I think there's a really neat lesson to come out of it. And I think it's that
Do mushrooms?
do mushrooms and then order delivery frozen yogurt. That was it. That's exactly where I was going.
That's
It speaks to what I think everyone kind of already knows, whether or not they want to admit it or not, in that the point of being here in the universe is to get close with people, is to share things, is to speak your mind, is to be yourself, is to let out all of the information that's inside of your head to get it out. And so it really comes back to we're building all of these weird devices
and
education.
education.
Like, you're on your
This is
cell phone
why
too much,
we
but
consider education valuable, because education is our flailing effort to make what's coming out of you more worthwhile.
yeah, absolutely. That's a really good point too. A little, there shouldn't be no filter on what comes out. There shouldn't be a stop.
No,
We
right.
shouldn't
That's the
stop
importance
things
of
from coming
freedom
out.
of
It should
speech.
just be adjusted
You
a
have
little
to
bit.
be able to talk, right? But you also, we culturally, we have to make allowance for the fact that 95% of it's going to be stupid.
But it's also
That sounds
all of the
bad, 'cause I
stupid
don't mean to
stuff
be calling people
is
stupid.
great too. You don't mean the people are stupid, because that'd be rude. You mean that a lot of the information is just not
Right.
useful. But it is also useful, because we need to know the things that aren't useful so that other computers don't bother
Right.
computing them. And unfortunately, we get stuck sometimes in loops where the software was written poorly, the social software maybe, and we get stuck on things like the Kardashians. And that poor girl is just the butt of like every complaint about pop culture in the world. But we're stuck in that loop a little bit. And the same can be said for a lot of things that people don't think are particularly good uses of resources. One that I would like to touch on, just to anger people, is fantasy sports. There's a lot of benefit that comes from that. People learn, there's so many people that know statistics and excel now because they do fantasy sports. Imagine if they were applying that to something else though. Go do something functional.
Anyway, I feel like that was an epic. Well, I was trying to sign off, and then we went an epic place with it. That's going to be good. But anyone that's still along for the ride,
Yeah, real good.
thanks for checking out the third episode, and we'll keep them coming if you keep the
Totally.
questions coming, which will make our life easier, because I keep
Yeah,
thinking about
thanks.
this, and I'm like, I don't know, I don't know what I'm going to talk about after we get through the 10 things that you and I usually talk about.
Ooh, that's where we are going to experience a lot of personal growth.
But I'm gonna run out eventually of things I feel like I can actually explain about mechanisms in the universe.
I pretty much ran out of that.
I guess
today.
we'll just have to do research, or you'll have to feed them to us and help us talk about it. But do that by hitting us on whatever channel you found us through.
Awesome.
Have a good
Thanks
week.
for hanging 10 with us. Stay groovy, everybody.
They don't know